everyone, welcome back to my channel. In previous videos, we study about modular arithmetic. From this video, we study 5th module on Engineering Mathematics 1. The subject name is Linear Algebra. Before going to the topic directly, first let us understand some introduction part of linear algebra. First topic is matrix. The set of mn number of elements or objects arranged in a rectangular array of m number of rows and n number of columns is called the m cross n matrix. The matrix can be denoted by capitals of alphabets and the order of a matrix can be denoted as n cross n. Let us show here. A is a capital of an alphabet which is denoted by the matrix, and the rectangular arrangement of this is called m number of rows and the rectangular arrangement of this is called m number of columns. Here these are all rows. Here this is first row, this is second row, this is third row, etc. up to mth row. In the similar way, this is first column, this is second column, this is third column, etc. up to n number of columns. So this is a m cross n matrix. Here these are all known as row. This is first row, this is second row, this is third row, etc. up to mth row. In the similar way, this is first column, this is second column, this is third column, etc. up to nth column. The set of mn number of elements or an object arranged in a rectangular array of m number of rows and n number of columns is called as m cross n matrix. So the matrix can be denoted by the capitals of an alphabet, and the order of the matrix is m cross n. Here this represents order of a matrix. That means the number of rows and the number of columns is nothing but an order of a matrix. So this is about matrix. So this matrix can also be written as simply capital A is equal to square bracket of Aij up to m cross n matrix. Here this is a element in the matrix which is of the form Aij. We have to substitute m and n values. This I and j lies between. Here I is lies between 0 less than or equal to I less than or equal to m, and j value is also lies between 0 and n. So 0 less than or equal to j less than or equal to n. So if we substitute I and j values 0 up to m and 0 up to n value, we will get an matrix of this form. So this is about matrix. Next we shall see what are all the application of linear algebra in engineering. Why is linear algebra is very essential for an engineering students. With the help of system of linear equations in linear algebra, circuit analysis is done for an electrical engineering. That is, in electrical engineering, system of linear equation is used as Kirchhoff's law are often represented using system of linear equations. Solving these systems helps to determine the currents and voltages in complex circuit. In the similar way, in civil and mechanical engineering, the equilibrium of forces in structures like trusses and frames is analyzed using system of linear equation. Another topic in linear algebra, that is transformations and matrices, are helpful in linear transformations including rotations, translations, scaling and projections are used to manipulate images and models in computer graphics. In robotics, transformation matrices are used to describe the position and orientation of robotic arms and other components in 3D space. Eigenvalues and eigenvectors in linear algebra are helpful in vibration analysis. That is, in mechanical engineering, eigenvalues and eigenvectors are used to analyze the natural frequencies and modes of vibrating systems such as beams and plates. In control systems, eigenvalues are used to study the stability and dynamics of control systems. The location of eigenvalues in the complex plane indicates whether a system is stable. So these are all some of the applications of linear algebra in many engineering fields. So it is very necessary to understand the linear algebra topics. Next we shall see some of the properties of elementary row operation. Here elementary row operation is nothing but the properties on a matrix. The elementary row operation or a transformation of a matrix are: first one, the interchange of two rows. Second one is the multiplication of the elements of a row by a non-zero scalar. Third property is the addition or subtraction of a scalar multiple of the elements of a row to the corresponding elements of some other row. Here, these three are the properties of a matrix which are helpful in solving the problems. Here, first one is we can interchange any two rows of a matrix. Here they will give one matrix. With the help of that matrix, we can interchange any two rows. Here, if they give 3 cross 3 matrix, we can interchange first row with the second row and second row with the first row and first row with the third row and third row with the first row and many ways. So the first property says if we interchange any two rows of a matrix, it is same as that of a before matrix. Second one is the multiplication of the elements of row by a non-zero scalar. Here they will give 2 cross 2 matrix or 3 cross 3 matrix. In that matrix we can multiply any scalar. That is, if we multiply any non-zero scalar with the matrix property retains. That is a second property. Third property is the addition or subtraction of a scalar multiple of the elements of a row to the corresponding elements of some other row. Here we can apply the property as we can add any two rows or we can subtract any two rows for a matrix. That is the third property. These are all very important in solving the problems. The above three operations are symbolically denoted as, here first one is the interchange of two rows. Here we are applying this property in the problems means we can write symbolically as, here Ri is interchanged to Rj. Here in the place of I we can take it as 1, in the place of j we can take it as 2. Here R1 is nothing but a row 1, R2 is nothing but a row 2. So first property is interchange of two rows. That means we can interchange R1 to R2 or we can interchange R2 to R1. This is because to solve the problem. Second one is the multiplication of the elements of a row by a non-zero scalar. We can write symbolically as Ri, we can write this to k into Ri. That is, if you multiply any scalar to the row, that is, if you multiply any non-zero scalar to the row, that is multiplication of element of a row by a non-zero scalar. Third property is the addition or subtraction of a scalar multiple of the elements of a row to the corresponding element of some other row. This is symbolically written as Ri is written as Ri plus or minus k into Rj. We can write Ri as this. We can add or subtract any scalar multiples to the rows. So this is about elementary row operations. Next we shall come across very important topic in matrices, that is echelon form of a matrix. A matrix of order m cross n is said to be in row reduced echelon form if first condition is the leading entry. Here the leading entry is nothing but the first non-zero entry of each row is unity. Second condition is all the entries below the leading entry is a 0. Third condition, the number of zeros appearing before the leading entry in each row must be greater than that appear in its previous row. Fourth condition is the zero rows. That is, zero rows means nothing but rows in which every entry is a 0 must appear below non-zero rows. So these are all the condition to holds row reduced echelon form. So this is a very important technique which is used to solve the matrix problems. Here a matrix of order m cross n is said to be in row reduced echelon form. Here they will give one matrix. We have to obtain it in a row reduced echelon form matrix. That means first step we have to find that the leading entry is nothing but first non-zero entry of each row is unity. Unity is nothing but 1. All the entries below the leading entry is 0. Here we'll take first entry as 1. Next, all the entries below this leading entry must be equal to 0. Next condition, the number of zeros appearing before the leading entry in each row must be greater than that of appear in its previous row. Fourth property is 0 rows must appear below non-zero rows. Let us take some of the example. Here this is m cross n matrix. Here this is precisely 4 cross 5 matrix. Here it contains 4 rows and 5 columns. Therefore, this is 4 cross 5 matrix. So, this is a row reduced echelon form matrix because here the first condition is the leading entry of each row is unity. Here in the first row the leading entry is 1, that is unity. In the second row, here 0 is not considered. Here the first non-zero entry is 1 here. Here also 0, here also 0, here also 0. The first non-zero entry in this row is 1. In the similar way, these values are 0. The first non-zero element is 1 here also. So the first condition satisfies, that is the leading entry of each row is unity. Next condition is all the entries below the leading entry is a 0. Here we have the leading entry as 1. Under this all the values are 0. Here also this is 1. Below values are 0. Here also 1, the below value is 0. So second condition also holds for this matrix. Similarly, the number of zeros appearing before the leading entry in each row must be greater than that of appear in its previous rows. Here fourth row is, it contains 4 zeros which is greater than that of the previous. That is, here we have 3 zeros. So the number of zeros appearing before the leading entry in each row must be greater than that its previous one. So here if we have 3 zeros, it is greater than that of previous because it is only 1 0. The fourth property is the zero row, that is row in which every entry is a 0 must appear below non-zero row. Here there is no 0 rows. We can take another example. Here this is also an echelon form of a matrix, that is the row reduced echelon form of a matrix, because all the entries below the leading entry is 0. Here first leading entry is 1. Below the first leading entry all the values are 0. Here also 0, here also 0. Next property, the number of zeros appearing before the leading entry in each row must be greater than this of previous one. Thus also satisfied. Here last one is the 0 rows. Here all the values are 0 here. All the values in a 0 row must appear below the non-zero row. Here this is a non-zero row. Here this is a 0 row which is appear in the last. So this is a row reduced echelon form matrix. We can take another example. Here this is 3 cross 4 matrix. So this also satisfies row reduced echelon form. Here we have to obtain a matrix in row reduced echelon form means all these conditions must be satisfied. So this is about echelon form of a matrix. We studied this echelon form of a matrix because in this module we have to study an important topic, that is rank of a matrix. So to obtain the rank of a matrix, echelon form of a matrix is very important topic. Next we shall study about rank of a matrix. Here definition of rank of a matrix says the number of linearly independent rows or linearly independent column of a matrix is called rank of a matrix. In simple words, rank of a matrix is explained as the number of non-zero rows or column of a non-zero matrix is called rank of a matrix. Here we have to obtain a rank for a matrix is nothing but the number of non-zero rows obtained by the row reduced echelon form of a matrix is nothing but a rank of a matrix. The rank of a matrix is denoted by the symbol row of A, and which is row of A is equal to R. Here R is nothing but a number of non-zero rows. Here we have to observe this. Here the definition of rank of a matrix is nothing but the number of non-zero rows or number of non-zero column of a non-zero matrix. Here to obtain a non-zero row means you have to apply row reduced echelon form of a matrix. In the similar way, to obtain the non-zero column means we have to apply column reduced echelon form of a matrix. So the rank of a matrix is denoted by the symbol row of A, and it should be always 0 less than or equal to row of A which is less than or equal to M, and 0 less than or equal to R which is less than or equal to M. Here since row of A is equal to R, this lies between 0 and M. Here M is nothing but a number of rows present in a matrix. Generally the rank of a matrix, it can be evaluated using echelon form of a matrix. So to obtain the rank of a matrix means first you have to use echelon form of a matrix, that is they will give one matrix. They are asked to find the rank of a matrix means we have to obtain the row reduced echelon form of that matrix. Finally, the non-zero rows in the obtained matrix is nothing but a rank of a matrix. So till here we studied some of the important introduction part of linear algebra. From next video we study about problems on rank of a matrix.